Not that many. I mean, it's definitely one of those gigantic numbers with lots of zeros. But in the grand scheme of things, there aren't as many zeros as you might expect. Our first question: where does firefly light even come from? Fireflies may look like they're full of glow-in-the-dark goo, but the light they give off actually comes from a thin layer on their surface. Lots of insects have glowing surface patches, and some of those patches have been studied carefully to calculate their brightness. A 1928 paper on beetles called headlight bugs, 2, found that their glowing patches, which were a little over a square millimeter in area, emitted about 0.0006 lumens of light. Fireflies have luminous organs, bright patches, that are about the same size as those of headlight bugs, 3, and their organs tend to have a similar peak brightness per area, so this figure is a good guess of the brightness of a firefly's lantern. Firefly lights aren't always on. They blink on and off, with patterns that vary from species to species and situation to situation. These flashes carry information, some of which you can decode using this delightful chart. 4. To get the brightest light, let's assume we're using a species with a mostly on-duty cycle, like a headlight bug. How does its 0.0006 lumen light output compare to the sun? The sun's brightness is lumens, so by simple division, it would take of those fireflies to emit the same amount of light. That is a surprisingly small number. Adult fireflies weigh about 20 milligrams, which means fireflies would only weigh about a third as much as Jupiter and 1/3000th as much as the sun. In other words, per pound, fireflies are brighter than the sun. Even though bioluminescence is millions of times less efficient than the sun's fusion-powered glow, the sun can't afford to be as bright because it has to last billions of times longer. 5. But wait, a mass of fireflies that big would run into problems. Besides the obvious problems with gathering that many animals in one place, the fireflies would block each other's light. The inner fireflies would be hidden behind the outer ones, and the total brightness would be limited. 6. Since the only light that matters is the light at the surface, we could imagine arranging the fireflies in a hollow sphere, with their lanterns pointing outward. Or, to make things simpler, we could imagine a single giant firefly. How big would it need to be? Since we know our firefly will need to give off about times as much light as a normal firefly, it will need a glowing patch, times larger. Since surface area is proportional to length squared, our firefly will have a body length, times longer than a normal firefly, which would make it about the size of the solar system. Since mass is proportional to length cubed, our firefly would weigh times as much as a normal firefly, which works out to about half as much as the entire Milky Way galaxy. Such a firefly would immediately collapse under its own weight and become a black hole. In fact, given the distribution of galaxies in our universe, there's an upper limit to how large black holes can grow, and this firefly would be bigger than that limit. That means our firefly will become the largest black hole in the universe. It would give off a lot of light as it devoured our galaxy, and then eventually it would give off none at all. Black holes last a long time, but they eventually evaporate through Hawking radiation. When the black hole era of our universe comes to an end, black holes will evaporate one by one, with the smallest evaporating faster. Since our firefly's black hole will be the largest one in the universe, it will be the last to evaporate, a final outpost of irregularity in a universe fading toward heat death. We should probably add that to the identification chart, just in case.